Hello students, how are you? Hope you are doing well. The question is, an electric dipole consists of point charges -1 picocoulomb and +1 picocoulomb located at 0, and 3 mm, 4 mm respectively in xy plane. An electric field E equals to 1000 volt per meter I cap is switched on in the region. Find the torque tau acting on the dipole. So the problem is based on the topic electric dipole and particularly the torque acting on the electric dipole when it is placed in an electric field. So the situation is like this. There is xy plane, this is the y-axis, this is the x-axis. There is an electric dipole, there is an electric dipole having minus q charge and plus q charge. The value of charge is given as -1 picocoulomb and +1 picocoulomb. These are the values of the respective charges, and this particular dipole is placed in such a manner that minus q charge, or we can say that -1 picocoulomb charge, is placed at 0, 0. So this is the location of the first charge, which is the negative charge, and the second charge of +1 picocoulomb is placed at the point 3, 4. So we can say that this length is 3 and this length is 4. So this particular dipole is placed in such a manner. Now it is said in this problem that the electric field is switched on in this particular field, in this particular region in which the dipole is placed. And the electric field equation suggests that this I cap suggests that the electric field is in the positive x direction. So the field direction is like this. This is the electric field. This is the electric field which is in the positive x direction. Now we can say that if it is in the positive x direction, this is the angle which the electric field makes with the dipole. This particular angle is the angle which the electric field is making with the dipole. Now the basic concept used here is the formula of the dipole in terms of the dipole moment, electric dipole moment, and the electric field. So torque tau equals to P cross E, where P is the electric dipole moment and E is the electric field vector. Now we know that P equals to 2AQ. The dipole moment, the magnitude of the dipole moment is 2AQ, where 2A is the length of the dipole. 2A is the length of the dipole. So if we want to calculate the dipole moment, then we have to calculate this 2A, this particular length of the dipole. So the length of the dipole can be easily calculated. We can easily see that suppose this is point O, this is A and this is B, then this is a right angle triangle with the right angle at the point A, and this is the hypotenuse. OB is the hypotenuse, and this length is 3 and this is 4. So this particular length is 3 square plus 4 square and the square root of it. So this is 25, square root of 25, which comes out to be 5. So the length of the dipole is, particular dipole is 5 mm, because this length is, the location is given in mm, millimeters. So we can put this value here as the value of P is 2A, which is 5 mm. 5 mm means 5 into 10 to the power minus 3 meters times Q. Q is the charge. Q is the charge which is given as 1 picocoulomb, which is 1 into 10 to the power minus 12 coulombs. 1 picocoulomb is equivalent to 1 into 10 to the power minus 12 coulombs. So this is 2AQ, which is P. And then we have multiplied by E. E is the electric field. The magnitude of the electric field is 1000 volt per meter. So it is in SI unit. We need not change this particular expression. So this is correct because this is the SI unit. And into sine theta. P cross E means PE sine theta. So what is sine theta here? Sine theta is basically the perpendicular upon hypotenuse, which is equal to 4 upon 5. This is equal to 4 upon 5. Now this 5 cancels with this 5, and this 1000 cancels with this particular 10 to the power minus 3, and we get this value of the torque as 10 to the 4 into 10 to the power minus 12. This is the value of the torque. So the unit we can also see, this meter cancels with this meter, and this is basically coulomb and this is volt. So this is volt into coulombs, or we can say that it is in Newton meter. Newton meter is also the unit of the dipole. So this is the value of the torque. This is the value of the torque acting on the electric dipole placed in the electric field, uniform electric field. Now suppose we want to calculate the direction also. We want to also know the direction also of this torque. So we can easily calculate the direction also by the vector concepts. According to the vector concept, suppose torque is a vector which is depending upon P and E, which again are two vectors, then the direction of the torque is decided in such a manner that place your right hand along the first vector, which is P. So the direction of P, which is electric dipole moment vector, is from minus Q to plus Q. So this is the direction of P. This is the direction of P. So we place our hand along the first vector, which is vector P, and rotate or curl our hand towards the second vector, which is E. So in this manner, we place our hand like this and rotate it in the along the E direction. The direction of E is the positive x-axis. So we have to place our hand like this and move or curl our hand like this. So in this way, the thumb, the direction of thumb is pointing inwards. Inwards means this is the negative z direction. So we can say that the direction of the torque is negative z direction. So this is the final answer. So hope you understand the solution. Thank you.